Okay, so adding these two vectors together graphically, first thing you do is you have to set you an axis. Alright. And what's the next step? You need to measure the angle so you'll know which direction it points. Okay, 112 is here in the second quadrant. So place your protractor down, measure 112, and then draw your vector 72 meters long. So whatever scale you plan on using. All right, so there's A. 72 meters at 112 degrees. Okay, and then what's next? All right, 64 at 17 degrees. Where should you start drawing then? Right, it does go up that way in the first quadrant, but where do I start drawing? Do I start drawing here? Okay, right, so at the tip of this arrow, you draw a new X and Y axis. Okay, so that's where you measure the 17 degrees. So put your protractor. Measure 17 degrees and 64 units long. Okay, so there's B, 64 meters at 17 degrees. All right, then how do I draw my resultant? How do I find my resultant? Okay, so we always start at the origin, so here's our starting point. So the starting point is the tail of your first vector. Your ending point is at the head of your last vector. So it points up and to the right. So that's my R. That's my angle. Okay? How do I find out how big R is? How do I find the magnitude of it? Right, you just measure it and use the same scale. So I measured it and you measure it and what did you get?
95.
Okay. Alright, I get about 93. Okay. You'll get a 5% margin of error. Okay, so if it's supposed to be 93, 5% would be 89 up to 97. Okay, so if you're within that range, somewhere between 89 and 97, you get credit for that.
Okay, I have a question. So
Yes.
How, since our like papers are smaller, how do you want us to like, for example, like when we use like really big numbers like 72, do we use like just centimeters or?
Your choice on how you could use inches, you could use centimeters, you could do individual marks. The bigger you draw it, the more accurate you'll be. So I mean, you could make it 7.2 centimeters. If it's 72, you could make it 7.2 centimeters long. Might be.
7.2. Okay, I got it.
Okay.
You have to find the angle, or?
Yes, we also have to find the angle. So how do you find the angle?
Yeah, so then how do you find the angle when it's like, when you're using like 7 that's the same, or is that the same thing where you just put it here?
Yeah, you just put your protractor down, line the 0 up on the 0 mark, and go around to your angle.
Is it like,
I get about 67 degrees. Okay, if your lines are not long enough, then you can extend that line, extend the R line out longer so it doesn't pass over your. Okay, did that answer your questions? Okay, so, you know, my suggestion, make it as large as your paper allows, gives you more margin of error, gives you a little bit better, allows you to measure the distances more accurately. Okay. Okay, so that's the graphical method. All right, so and you can use this for 2, 3, 4 vectors. You can use it for any number of vectors you want, adding them together. Okay. All right, so what we're looking at next is called the analytical method. So the question is, how can we use sine, cosine, tangent function, and Pythagorean theorem to solve this same type of problem? Okay. All right. So all right. So the way that we do this is that if I can, so the first step is we're going to resolve or deconstruct the individual vectors, resolve them into their components. All right. So what we're going to do is I want to find out what is this x component and what is this y component. Okay. So if I know vector A is 72 meters at 112 degrees, how can I find this x and this y? All right. Sine for this one since it's opposite, and cosine for this one since it's adjacent. Okay. So I can go, my AX would be A cosine theta, so it's going to be 72 times cosine of 112 degrees, and I'm going to turn the projector off. And the y would be A sine theta, so that would be 72 sine 112 degrees. Okay, so now you'll need your calculators out. So, what we're going to do is we're going to do this using sine, cosine, tangent. Instead of using the ruler and protractor, we're going to use our trig functions. And it starts with resolving the vectors into components, okay? Or deconstructing it so that we have the x and the y. Okay, so we're making like a little right triangle here using cosine, sine, cosine. Okay. So you get 72 cosine 112. And I got a negative number, negative 26.97. Why is it negative? Exactly, we're going to the left. This points to the left. That's the negative direction. Okay. So if I calculate the AY, okay, we should get a positive number because it's pointing upward. Okay, so 72 sine 112. Okay, we get positive 66.76. Okay, we're going to do the same thing for the B. We're going to resolve it into components. So I want to find out what is dx and what is dy. How would I find dx and dy? Right, same thing. Dx is on the adjacent, so that's cosine. Dy is opposite, so sine. So dx is the cosine theta, so 64 cosine 17 degrees, and the dy is the sine theta, well, 64 sine 17 degrees. So 64 cosine 17 gives what value? Okay, you should have your calculators out doing this along with me so that you can have practice doing it. Okay, 61.20. And by 64 cosine, 64 sine. Okay, 18.7. Okay, so. All right, so my question is, how does that help us? All right. So the goal is, we want to find out what R is, and we want to find out what this angle is. Okay? So if I know the sides of this right triangle, okay, if I know Rx and Ry, so if I know the X and the Y, how could I find the hypotenuse? Right, right there. And if I know the Y and the X, or the opposite and the adjacent, how could I find the angle?
Tangent.
Right, tangent of the angle is opposite over adjacent. Okay? So the angle would be the inverse tangent of that ratio.
Yeah. I'm a little confused on how you're getting the angles.
They were given.
Oh, I didn't see that.
Okay. Using the same two vectors that we had. Using that. Okay, so from this picture, can anybody tell me how to find out what Rx is? Or maybe it'd be easier if I asked, how would you find out what Ry is? AY? Well, AY only gets me this far.
You would have to be AY plus BY.
Exactly. So RY would be AY plus BY. Okay. So what do you think about RX? How would I find RX?
It would be
Right, it is, well, it's a negative number, but it's still AX plus BX. It's just this happens to be a negative number. Okay. All right. So if I add those together, so ax plus bx, what does that give me? 61, 2 minus 26.7. That gives me 34.23. All right, so now I know what this length is. 32.23. Okay. Add these together, just like you said. AY plus BY. So add those together. 66.76 plus 18.71. And that gives me 85.47. Alright, so I'm going to erase some things so maybe it's so you can see. So I have this right triangle. So how do I find R? Got a right triangle, I know X and Y, how do I find R? Okay, Pythagorean theorem, like we said before. So R equals the square root of Rx squared plus Ry squared. So the square root of 34.23 squared plus 85.47 squared. Take the square root. And we get 92.1 meters. Okay, when I did it graphically, I got 93. So we're close. Okay, did a good job. So if you got something close to 92, when you did it graphically, then you measured accurately and so forth. Okay, how do I find the angle? Well, the angle is be the inverse tangent of the y over the x. So the inverse tangent of 85 over 32. So inverse tangent 85.47 over 30. And we get 68. And that was very close to what we measured, okay, using the graphical method. All right, so the graphical method can be just as accurate, depending upon the care that you take in drawing the axes and measuring angles. But this is the analytical method, okay? All right, so let me look at the notes. Does anybody need to take a picture of that or anything before I erase it? Okay, we are going to do another one together. Okay. All right. Okay, so I'm going to erase that. Okay, so going back to the notes we were looking at yesterday, it goes through that same procedure, all right? So the analytical method of vector addition does employ some simple trigonometry. So rather than using the ruler and the protractor, using the trig functions and Pythagorean theorem. All right. Okay, so. All right, so looking again at this analytical method, the summary here is, the first step is to resolve your vectors into components. All right, so that means if you've got vector A, and it's at angle theta A, then you need to find out what's the x component and what's the y component. Okay. And the way we're going to do that is your x component, all right, if your angle is measured on this this coordinate system, with 0 being on the positive x and you're measuring counterclockwise, then your x component will always be the same, a times the cosine of the angle. All right. And the y component will always be the same. It's the opposite side. It would be, the y component would be a sine theta. Okay. All right. Now that's true only if your angle is measured on this coordinate system and it's measured from 0 counterclockwise. Okay. Then that will always be how you calculate the x and the y components. Okay. Let's see. So for the B, we do the same thing. All right. Find the x component, find the y component.